folks. In today's class, I'm going to talk about chapter number 16, and we will talk about the nucleus. Nucleus, that's what we're going to talk about in our today's class. So, nucleus, first of all, how does an atom look like? An atom constitutes of electrons, protons, and neutrons. Protons have positive charge, electrons have negative charge, and neutron has no charge onto them. And if I try and draw the diagram of an atom, this is how it's going to look like. I'm using the planetary model to represent the atom. So there is a nucleus, and then around the nucleus there are electrons which revolve around the nucleus. So these are the electrons, and this nucleus constitutes of two things: protons and neutrons. Proton plus neutrons. So the majority of the mass is inside the nucleus of the atom. Now, when we talk about the nucleus, there will be three things we'll talk about. One is atomic number, and then the second one is neutron number, neutron number, and then the atomic mass number, atomic mass number. So atomic number is basically the number of protons which are in an atom. So it is the number of protons. Neutron number is number of neutrons, as the name suggests, number of neutrons. And atomic number will be the sum of protons plus neutrons. That is the atomic number. So how are we going to represent it? It is represented, let's say this is X is the element, and I'm going to represent the atomic number on the bottom here. Let's say 6, and this is 12. So atomic mass number, I should have written here atomic mass number, which is the sum of proton and neutron. So atomic mass number will always be the bigger out of the two. So if this is an element written here, so you wanted to figure out which one is the atomic mass number and which is the atomic number, always atomic mass number is bigger. Sometimes you will also see the books end up writing this way also. This is correct also, but you have to identify which one is the atomic number and which one is the atomic mass. You can always figure out, as I earlier said, by the one which is the highest or the bigger one, that is the atomic mass number. Now, in this one, I wanted to find the number of protons. Number of protons is equal to 6 in this case, and that is also called as atomic number, as I said, number of protons. And number of neutrons, if I wanted to find out, so this is the atomic mass. Atomic mass is equal to sum of protons plus neutrons. So proton number in this is 6. We wanted to find out the neutron. Atomic mass is 12. So 12 minus 6, this goes on the other side. That's going to give me the number of neutrons. And we will be able to get the answer. And one thing I want to tell you is this atomic number. This thing decides which element we are talking about. So this element in this case is carbon, because the atomic number is 6. So if you have an element 6 and this is 13, this will not define which element we are talking about, whereas this one will always define. If this changes from 6 to 7, then it will become nitrogen. If it changes from 7 to 8, this will become oxygen. This number can be anything. This can be 15, 14. So this number does not define which element it is. All right. Now let's jump on to a simple example based on whatever we've learned. So gold, AU is represented as gold, 7997. And I wanted to find out the number of neutrons. So number of neutrons will be equal to 197 minus 79, and that's going to be 118. Now, the next thing, isotopes. Isotopes. Isotopes means same atomic number, same atomic number, but different mass number. So I'll take an example, H11, H12, H13. They all are represented with the symbol H because they all belong to the family of hydrogen. Why they belong to the family of hydrogen? Because this is 1 down here. This is 1. But the mass number is different. Mass number 1, 2, and 3. So these are called isotopes of an element. With isotope, as I said, means same atomic number but can have the different mass number. Now, if I go back into the basics and look into the mass of an electron, is mass of electron, that is equal to 9.11 times 10 raised to the power negative 31 kg. Now if I look at this number is very small. So scientists came up with another units so that they can represent the mass in some numbers which don't look that small. So they came up with the atomic mass units to represent the mass of the electron, and proton and neutron. Now, one atomic mass unit, so it's like a conversion scale. For example, 1 meter equal to 100 centimeter. So same way they came up with this new conversion scale. One atomic mass unit, which is represented with U also, 1 U is equal to 1.660539 times 10 raised to the power negative 27 kg. Now, if I were to convert the mass of the electron in terms of U, that will come out to be mass of the electron in terms of U, mass of electron is equal to 5.485799 times 10 raised to the power negative 4 kgs. Oh, this much U, shall I say, as I said, in terms of U. And mass of proton mass will be equal to 1.00726, and neutron mass will be, in terms of U, that will be equal to 1.008665. Again, how we figured out these numbers? By taking the mass of the electron and dividing it by this number, mass of the proton, dividing it by this number, and mass of the neutron, and divide that by this number. You will be able to get these, dividing it by this number, shall I say, dividing it by this number, that's how you're going to get this number. So I'll show you also. I accidentally said it wrongly. So if the mass of the proton is 1.672622, multiply by 10 raised to the power negative 27. And you don't need to figure out all these numbers. These numbers will be given to you in the formula booklet. On the top right corner of the formula booklet, you are given the mass of the proton, electron, and neutron. If it is not given, you can write it down also. This number divided by 1.660539 multiplied by 10 raised to the power negative 27. Make sure you put them in the bracket. Once you're going to solve them, you're going to get the mass of the proton as 1.007276. And same way, the mass of the neutron is 1.674924 multiplied by 10 to the negative 27. Once you're going to divide this number with 1.660539 multiplied by 10 to the negative 27, you're going to get the number something like this. All right. So this was the mass of the electron, proton, and neutron in terms of atomic mass units. Now, the next concept we'll talk about, that is binding energy. Binding energy. So what happens in nature when the electrons, they move at a fast pace. So when these electrons collide together or come together, they form a new nucleus. A new nucleus is formed. For example, these are the four nucleons or nucleus which are traveling. So nucleus 1, nucleus 2, nucleus 3, nucleus 4, and all of them are traveling at the speed of light, that is 3 times 10 raised to power negative positive 8 meters per second. So they are traveling at that speed. Once they interact with each other or collide with each other, they will form a new nucleus. So four of them will come together, a new nucleus has been formed. And this nucleus, once this nucleus is formed, a large amount of energy is liberated. A large amount of energy is liberated. That is called binding energy. So you need to notice this. If we wanted to make a specific nucleus, these two have to be proton, means any two of can be proton, and the other two have to be the neutrons. So once two protons and two neutrons gonna collide together, they will form a nucleus, and you will be able to get the new nucleus. And in this case, it'll be a helium nucleus. Now the energy is liberated, as I said, this is called a binding energy. Now how this energy is liberated, that's also a question, that all of a sudden they collide together. How come so much amount of energy is liberated, and how come the new nucleus is formed? So scientists figure out that there is the mass, or there is a mass defect. And what is the mass defect? So I'll talk about talk about the mass defect with the help of an example. So if, let's say, if I have a container and I have 4 apples here, 1 2 3 4, I'm gonna throw these apples in this container, and let's suppose the mass of each container is 1 kg, and total mass should be, once they come together, it should be 4 kgs. But all of a sudden, when you throw them in this basket, you measure the mass as 3.5 kgs. So what's happening? So there is some loss of mass. So earlier total mass should have been 4 kgs, but you measure it as 3.5 kgs. So there is a loss of mass. How much? Delta m will be equal to 0.5 kgs. And that 0.5 kg will convert in form of energy, delta mc square. And that is the energy which will be produced. So 0.5 multiplied by 3 times 10 raised to power 8. That is the energy produced. And this is the binding energy, amount of binding energy, which is caused by this mass defect. Here in this case, I've taken some random numbers, kgs. It cannot be in kgs, but I just wanted to give you guys a simple example. So in this case, there were four nucleons, 2 protons, and 2 neutrons. Okay, one thing which I also wanted to tell you, that a nucleon can be a proton or a neutron. So when I'm using the term nucleon, so nucleon can be a proton or a neutron. All right. So this is a nucleus, as I said. This is made by the combination of 2 protons, proton 1, proton 2, and 2 neutrons. They travel at a very fast pace, they come together, they make a new nucleus, and the mass of this nucleus will come out to be the less than the total mass of these 4 nucleons. So let's take an example on binding energy and the mass defect. So I'm going to take an example from page number 795. Page 795. So I'll encourage you guys to read into that example also so that we can do it together. So mass defect, we have to find out. Find mass defect in expressed in kgs and binding energy and the binding energy. Mass defect and binding energy for carbon 12 nucleus. Okay, so this is given to me, carbon 12 nucleus. Now, first of all, in case of carbon, how many neutrons are there and how many protons there? Carbon 12 has 6 protons because it's a carbon. That's why 6 protons. And then if there are 6 protons, how many neutrons will be there? 6 neutrons. 12 minus 6 is 6. So we figured out the number of protons and number of neutrons. Now I will find out the total mass. Total mass, ideally what it should be. So 6 times, what is the mass of a proton? Mass of a proton in terms of U, we figured out earlier, that was 1.007276. I'll encourage you guys to keep this number as long as possible, at least up to 6 places, so that you can get close to the accurate results. Plus 6 times mass of a neutron. Mass of a neutron, that is equal to 1.008665. And once I'm going to calculate, the total mass will come out to be well, I have to do the calculation, so I'll encourage you guys to do the calculation on your end too. So this will be 1.007276 multiplied by 6 plus 6 times 1.008665. That is 12.095646. Now that's the total mass. Means if I have to show this with the help of visualization, a carbon 12 nucleus has 12 nucleons. So there are 12 nucleons. 6 of them are protons, 1, 2, 3, 4, 5, 6, and 6 of them are neutrons. So if I were to weight in ideal circumstances, this should have been the mass of the carbon nucleus in terms of U. But when this nucleus was formed, scientists measured the mass of the carbon nucleus C12 is 12U. And how I was able to figure out? You can go to page 881. Page 881, you will be able to find a chart and you will be able to see these numbers there. And if I ask you a question like this on the exam, I will provide you all these numbers which are there on page 881, and the table is 7.5. All right, now this is what scientists measured. Now how much mass is lost? Delta M value will be equal to 12.095646 minus 12, and that's gonna come out to be 0.095646. Notice, if you see the book, my number is a little different from the book. It's totally fine in these questions, because if you're gonna do your calculations, your number will also come out a little different, but it should not be a huge difference. So something like this number should not be 0.285. That's a huge difference. So it should be 0.09. I matched the answer up to 2 decimal places. So your answer should match at least up to 2 decimal places. All right, so we've got the value of delta M, and now I wanted to find out how much energy is being lost because of this. So energy lost will be equal to delta MC square, delta MC square. And how I'm going to figure out? Delta M value is 0 0.9, 0 0.095646 multiplied by 3 times 10 raised to the power 8 meters per second. If you are converting it into if you are converting everything into joules, which is the standard unit, then you need to make sure you convert this number into kgs also. How are you going to convert U into kgs? I've told you earlier, by multiplying this number with 1 point. I have to multiply this number with 1.6. Let me sharpen it up. 1.66059 multiplied by 10 raised to the power negative 27. And if you're going to multiply all these three numbers, you will get the final answer in terms of joules, which is 1.476 approximately times 10 raised to the power negative 11 joules. This part of your answer should match at least. All right, even if this part is different, that's totally fine. So hopefully you were able to understand how to solve this, and make sure you don't forget to square it, otherwise your answer will be wrong. Other way, if you don't want to follow this, you can write delta MC square, binding energy, and 1U produces 1.492 times 10 raised to power negative 10 joules. You can note it down on your formula booklet if you wanted to, or you can write it as equal to 931.5 MeV, mega electron volt. 1U equal to this much volt, and you can apply any process to get your answer. So if 1U is equal to this much, so if you wanted to find the final answer, 1U equal to 931.5 MeV, you wanted to find out this U, the one which we got, this value. So 0. 0. Oops, it's slowing down. So 0 decimal, let me erase this. So this will be equal to how much? I have, my battery is low, so that's why I'm rushing it up. 0.09565646 multiplied by 931.5. That will give you the answer in terms of MeV. That will come out to be 92.16 MeV. And you can note down this also on your formula booklet, 1U equal to this MeV. So hopefully you were able to understand the concept. I'll see you with another video. Till then, goodbye.